is Robert Hunting. This is one of several in a series aimed at explaining how young children learn mathematics. You can probably remember learning geometry at school, how a right angle is 90 degrees, the names of different shapes such as triangles, rectangles, pentagons and so forth, along with their properties, about parallel lines, perpendicular bisectors, symmetry, and the famous Pythagorean theorem. The square on the hypotenuse is equal to the sum of the squares on the other two sides. School geometry for hundreds of years has been based upon the work of Euclid, a Greek mathematician who lived around 300 BC, whose Elements has had an enormous impact on generations of students. Euclidean geometry is based on 5 fundamental axioms or postulates. First, a straight line segment can be drawn joining any 2 points. Second, any straight line segment can be extended indefinitely in a straight line. 3. Given any straight line segment, a circle can be drawn having the segment as radius and one endpoint as centre. Fourth, all right angles are congruent. Fifth, in a plane, given a line and a point not on it, at most one line parallel to the given line can be drawn through the point. The geometry of Euclid contained arguments, theorems and results based upon the foundation of those 5 axioms. For centuries, this body of deductive proofs was, in the West, the introduction to a method for establishing mathematical certainty, deemed essential for a classical mathematical education. During the 19th century, other geometries became accepted as legitimate. These geometries, which included hyperbolic and elliptic geometry, allowed variations to the so-called parallel postulate. But the initial geometric ideas of young children are not Euclidean. Their beginning spatial concepts follow what has been called a topological development. Put simply, this means that spatial position and awareness involve notions of proximity, continuity, order, and enclosure. Proximity deals with how close or distant an object is from oneself or from other objects. Continuity and separation describe how one might consider objects as a whole or as a set of separated units. When 2 objects close together are considered to be arranged one before the other, order is imposed. Enclosure is typified by a realization that one's relation to an object may be one of outside or inside. An infant will climb inside a container and thus become enclosed, or they will place an item inside a container, thus enclosing that item. Much of a child's play entails explorations of their spatial world. Look at these twins, aged 14 months, moving from the outside to the inside and outside again of a wooden stool. Young children love to climb into and out of objects and containers. They are gaining an awareness of enclosure, including what happens when objects are enclosed and what happens when objects enclose other objects, including themselves. Down the track, children come to understand the idea is contained in. In Euclidean geometry, a square is a quadrilateral, that is, a 4-sided flat shape. A rectangle is also a quadrilateral. A square is a special kind of rectangle where all 4 sides are of equal length. So the class of all squares is contained within the class of all rectangles. The formal mathematics curriculum that includes topics from Euclidean geometry represents part of our rich cultural heritage. It is important that parents and teachers be aware of children's natural experiences of space and how they relate to their surroundings. The challenge is how to introduce formal topics in a way that connects with children's lived experience. You can learn more about how children learn mathematics by obtaining my books, What Children Can Teach Adults About Mathematics, and the how and why of teaching elementary mathematics. Available through the iTunes Store, Amazon or Google Books. Visit my website at www.palm-ed.com or my Facebook page at www.facebook.com/Hello Palm.